This is the note taker on scientific method and experimental design, and with this note taker we are going to focus on our variables. And at the beginning we'll talk a little bit about types of data. We spend all day of our lives making observations. When we use our five senses, we can see stuff, smell stuff, taste stuff, I can hear things, and I can touch things. And from these, I can make observations. Now, in our science class, we're going to talk about two different types of observations. One is qualitative, the other is quantitative. And if we look at the base words, especially with quantitative, that's the easier one, our base word in that is quantity, and that's an amount. So when we talk about observations that are quantitative, they're going to be observations that measure. Our qualitative observations, we're talking about the quality of something. These are going to be observations that describe. So on this slide, I've put some examples for you. With the qualitative, which are the descriptive observations, I can see that the shirt is red. Red is an adjective that describes the shirt, and it makes it qualitative or descriptive. I can have a blue pencil, a dark sky, a friendly dog. You can have angry parents, or you can have happy parents, depending on the phone calls your teachers make home. On the flip side of that, we're going to talk about quantitative data or observations. Quantitative, talking about quantity, is going to be a measurement of how many or how much. So I can have a set number like a class of 28 students. I'm using a specific number there, so that's a quantity. However, we do have some words like many, several, some. These are going to be quantitative observations. However, they're not going to be specific numbers. It's going to be a general number. I have some money. That's quantitative. The examples here, I put many books or several lockers. In class, we'll be doing more practice deciding whether observations are quantitative or qualitative. Once we have made an observation, we can then come up with or create an inference. It's a big fancy word for saying I'm trying to explain why I see something, why I smell something, why I taste certain thing, hear something, touch something. So down below I have an example of a few inferences that you may make when I make an observation. Now, the one thing to remember is that inferences are not final. As we discover new information or collect more evidence, it is okay to go back and change what your original explanation was. So, the observation is, I'm driving by the school and I see through the window that Miss Ennis's classroom is dark. So the classroom is dark. That's my observation. My inferences is how I'm going to explain why the classroom may be dark. Maybe the lights are off. Maybe Miss Ennis is in there teaching, you're off of school because you're sick and your parents taking you to the doctor. So when you go by, Miss Ennis might be going through the notes and have the lights off. Or, I didn't tell you what day it was, maybe it's a Saturday. So you're driving by and you see that the lights are out in Miss Ennis's classroom, but it's a Saturday, so maybe your inference is school is closed. Or, if it had just stormed, we might be having a power outage. So each of these are good inferences for that observation. However, we're not going to know which one is the correct one until we collect all the evidence. In class, just like with the practice on observations, we will have more practice making inferences in our class. Using our observations and our inferences, that is what's going to set us up and allow us to collect information from our world around us. And then we can start to ask questions about why things are the way they are. And we're going to then eventually get to doing experiments in class. However, before we get to experiments, we have to understand the different parts. And probably the most difficult for students to understand every single year are going to be our variables. Now, in general, a variable, the definition is a factor, condition, or relationship. It can change or purposely be changed in an experiment or in everyday life. That's what we mean by an event or a system. And when we want to see what variables are, we can ask ourselves, what factors will affect the outcome? So here on the slide, I've put an example of a question. What factors will affect the sprouting of a seed? Well, there are lots of different things that will affect the sprouting of a seed. It may depend on how much water that it gets. It may determine or be determined by what type of soil you plant that seed in. It could be affected by how much sunlight it's getting, because that sunlight, even though it won't hit that seed that's under the ground, it will change the temperature of the soil, and the seeds do need a certain temperature to grow. So all these are examples of variables that we can have based on this final outcome, which is the sprouting of a seed. In class, I will have a list of more outcomes, and we'll work together as a group to come up with things that might affect these outcomes. This is where it gets more difficult. We need to talk about the different types of variables. In our experiments, there are going to be 3. You need to have an independent variable, a dependent variable, and you're probably going to have quite a few constants. Definitions for each of these words. Your independent variable is the factor that you, as the person doing the experiment, you are purposely making different between each group you're testing. So if I, for example, wanted to test which liquid allowed plants to grow the best, I would have 3 plants. They would all be the same type of plant. In one, I would put maybe Coca-Cola. In another, I'd put milk. And in the third one, I'd probably use water. The different liquids that I picked and purposely changed the liquid, that would be my independent variable. A good way to remember this is always picture yourself doing any experiment we talk about, no matter whose name I give you. Always think about it as I am doing the experiment. Well, if you think that I is the first letter of independent, it's what I am purposely changing and testing in the experiment. The second variable is your dependent variable. These are factors that are affected by the change you made. Usually, it's what you're going to be measuring. So in scenarios, when we're trying to pick these out in class, you may see words like she measured, and whatever follows that, that would be your dependent variable. I recorded, I counted, I determined. These are all verbs that are used to find what that dependent variable is. So if I put the different liquids on the plants, the way that I'm going to know which liquid was the best was how tall my plant grows. So I would be measuring the height of my plant. So the height of the plant would be my dependent variable. Constants are anything that stay the same. There are probably going to be lots and lots of constants in each of the experiments we talk about. The plant experiment that I just gave you in my example, I would need to keep the same size and type of flower pot, the same amount and type of soil. The plants would need to get the same amount of water, the same amount of sunlight, be kept in the same temperature. Each of these are things that need to stay the same so that we know which one of our independent variables, what we've changed and decided to do different with each group, which one of those has the most effect. Now, when we look at an experiment, there can be lots of constants. You may have 1 or 2 dependent variables, but every experiment that's done properly should only have 1 independent variable. On the next couple of slides, I have a scenario. On the first slide, I'm going to read through it with you. And then on the several slides following, we're going to identify the independent, the dependent, and the constant variables within the scenario. You will be doing more work with these in class. The scenario I'm giving you for an example. Susan wanted to determine what type of bird seed attracted the most birds. So she chose 3 types of seeds. She put equal amounts on 3 identical plates. She placed one of the plates on a stump. She left it there for 1 hour. And while it was sitting out there, she sat in her house through her window and she counted and recorded how many birds came and ate from that plate. After an hour, she moved that plate. She waited for a little while, put the second plate out, did all of that again, and then she repeated with the third plate. So when she was done, she would know how many birds came to eat for each plate, and that would give her an idea of which bird seed they preferred to eat. On this slide, I have underlined in blue the independent variable, the one that she is purposely making different for each of the 3 groups she's going to test. On each plate, she put a different type of seed. So since that was what she did different, that is her independent variable. On this slide, I have underlined in red the dependent variable, what she is measuring. If you look at that sentence, if you go back just a little bit before where I underlined in red, the sentence starts, she counted and recorded. These are great verbs to show you that this is the data she's collecting. So what she was writing down was how many birds ate from each of the plates. That is her dependent variable. The final slide here, I've underlined quite a few things in green. The green is going to represent our constants. These are anything that stayed the same. So if we look at our scenario, she picked 3 identical plates. The word identical means same. That's kind of a clue that that's a constant. On each plate, she put equal amounts of birdseed. The word equal means the same, another good clue. And then there are 2 other things I've underlined in green. She put each plate on the same stump in her yard, so she used the same location each time. And she left each plate out there for 1 hour. So everything I've underlined in green are all things that stayed the same. In class, we will be working on some more scenarios. You will be underlining in blue and green and red. So if you have a chance and you can remember, please bring those colors to class with you. Please don't forget to complete the assessment that follows this video. The link should be right below the video on our Google site.